Hello everyone, this is a racing game that took the first place in the competition from the Giant 4 store on Alex Guyver. Let me show you how it works and then I'll tell you how I put it together and show the program. Turn on the game with the switch, enter the menu. Here you can select the difficulty level. It affects the speed of movement and the length of free space between obstacles. More free space between obstacles means it's easier to squeeze through it. You can also see your maximum scores on each difficulty level. Here we can select the difficulty level for which we want to see the record. To exit, press again. Let's select the level and start the game.
Schnie, schna, schnappi, 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 schnapp. Schnie, schna, schnappi, 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 schnapp.
On the recording, you can see that the objects do not have time to light up completely, but in reality it looks much better. Now let's crash into an obstacle and we'll talk about how I've built it. You can find assembly instructions on Project's GitHub page. To assemble it, you will need a smartphone tripod, Arduino Nano 16x2 screen with an I2C module, a joystick, a battery compartment, and some wires to connect it together. First of all, you need to attach the joystick to the tripod. I did this using 2 small screws. Next, we install the screen on the tripod as you can see on the first photo. For fastening, I have used glue gun. The screen fits perfectly, but you will have to cut a little piece of plastic from behind of a tripod to fit contacts and an I2C module. It is better to use a battery compartment with a built-in switch like I did. If your battery compartment doesn't have one, you can turn the game on and off by removing the battery, or you can install a separated switch. It is also better to use a compartment for little finger batteries, not for finger ones, because they are lighter. There was no compartment for 4 batteries in the store I bought it from, so I bought 2 compartments for 2 batteries and connected them by gluing them to a piece of plywood. The wires are connected according to this scheme. Now we wrap the Arduino in a piece of an anti-static bag and wrap it with tape. We place it between the legs of the tripod and wrap the legs with tape too to make them stay in this position. Now let's talk about the program. I was praised for the well-written code after the competition, but I wrote it long ago and I don't think it's good now, but it works perfectly and I don't want to break it. The famous saying goes not to touch anything if it works, so I will follow its advice. At the beginning, the program imports the libraries it needs and announces global variables. The printCar function displays the object of the car on the display. If the variable pos is 0, then the machine is in the first position and is drawn on the left, otherwise on the right. Right 1 displays the front end of the car. Right 2 displays the back end of the car. The turn function changes the position of the car on the display when you turn the joystick. An allograde reads the position of the joystick. If the car crashes into an obstacle when turning, then the function returns 0, otherwise 1. And this is one of the things that should be redone, because usually in programming 0 means that everything is fine. When successfully performed, this function calls the printCar function to display the car after changing coordinates. The moving function moves all objects forward by 1 cell. If the obstacle is spawned on the other side immediately after the previous obstacle, then there will be a situation in which the player's passage will be blocked. In this situation, the moving without ran function is called and it moves all objects forward before displaying the next block. The dispor function displays the level of difficulty on the screen and the points scored by the player in the record display menu. The max scores function changes difficulty in the records menu. The disdiff function changes the name of the difficulty level on the screen and sets parameters for the difficulty level selected by the user. The difficulty function changes difficulty in the main menu. The setup function prepares the Arduino for operation before starting the game. The loop function is like the main function. All the functions above are called from here. After clicking the button, the difficulty selection function starts. If you do not write the random seed function here, then the Arduino will output the same random sequence of numbers at every start. After difficulty is selected, the car displays on the screen and the object generation cycle starts. A number from 0 to 2 is generated with the same probability. 0 means no obstacle. 1 means it is on the right side, 2 means it on the left side. If it is necessary to create a gap between the obstacles, the moving without ran function is called. If you crash into an obstacle at any of the stages, the brake operator is called and the cycle stops. We move all obstacles 1 block forward and insert the next one from behind, or don't if there is no obstacle. The last 2 variable calculates the number of blocks generated 1 by 1 in 1 row. With it, I made the obstacles not longer than 4 blocks. I just did not want the game to have very long obstacles. The turn function checks the position of the joystick and changes the position of the car on the screen. Program adds 1 point for each passed block. The velocity variable is responsible for the speed of movement and depends on the difficulty level. It simply changes the delay between the generation of new obstacles. After breaking the cycle, the game displays the game over message and writes your score on the screen. If the number of points is higher than the record, then it rewrites the record value. Then the game waits for the button to be pressed and the main menu starts again. As a result, we got an interesting and unique game made by ourselves. That's all for today. Bye, everyone.